The supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
Astronomers around the world held their breath as the alert came through. A colossal object, roughly the size of Manhattan, had just breached the outer boundaries of our solar system. Unlike countless comets and asteroids catalogued over centuries, this one was different. Its bulk dwarfed known wanderers, its trajectory steep and foreign, and its destination chillingly precise. A direct approach toward 3I/A TLAS, the third confirmed interstellar object ever spotted passing through our cosmic neighborhood. The scene is more than astronomy. It's a high-stakes drama unfolding on a galactic stage. Two alien travelers, forged in distant star systems, are converging in the same solar corridor within sight of Earth. Scientists are scrambling, observatories are recalibrating, and questions hang heavy in the night sky. Is this a chance alignment of wandering masses? Or are we witnessing the reunion of ancient companions flung apart light years ago? Whatever the truth, humanity stands at the threshold of one of the most extraordinary events in astronomical history. Before we can grasp the magnitude of this approaching giant, we need to revisit the smaller but already legendary object it's heading for, 3I/A TLAS. Discovered in 2019 by the Asteroid Terrestrial Impact Last Alert System, hence its name, ATLAS, this interstellar body was quickly identified as the third of its kind. The first was Oumuamua in 2017, a cigar-shaped enigma that baffled scientists with its strange acceleration. The second was 2I/Borisov in 2019, a more comet-like visitor that spewed gas and dust across its brief passage. Then came Atlas, smaller than Borisov but with even stranger behavior. Unlike typical comets, ATLAS fractured and disintegrated as it neared the Sun, releasing bursts of volatile material that suggested it carried exotic chemistry. Its brightness varied unpredictably, and its orbit confirmed what many already suspected. It wasn't born here. This fragment had crossed interstellar gulfs, possibly carrying clues from a long-lost star system. Even in isolation, ATLAS was a treasure trove for planetary science. It represented a time capsule from beyond our heliosphere, a messenger carrying chemical and physical fingerprints from a birthplace light years away. But no one could have predicted that its path would intersect with a much larger interstellar traveler, one that could change everything we thought we knew about cosmic migration. The discovery of the giant object wasn't immediate. At first, it was nothing more than a whisper in the data, small gravitational disturbances tugging on icy bodies far out in the Kuiper Belt. Their orbits shifted subtly, as though some unseen hand was pulling them off course. Teams across different observatories began comparing notes. Was it an error in the models, instrument noise, or had something massive truly entered the system? The evidence stacked up quickly. Tiny but measurable wobbles in asteroid positions, faint irregularities in the paths of scattered disk objects, too consistent to ignore. Then came the glint, a barely perceptible shimmer of sunlight reflected from something huge, caught in long exposure telescope arrays. That flicker was all it took. Within days, observatories in Hawaii, Chile, and space-based platforms locked on. The intruder had revealed himself. What they saw defied expectations. It wasn't just large, it was vast, stretching across kilometers in irregular silhouette, darker than typical comets, less reflective than icy asteroids. Its density profile suggested materials forged under extreme conditions. And most startling of all, its trajectory pointed directly toward 3I/A TLAS. This was no idle drift through the solar system. This was a headlong convergence, a cosmic crossing so rare that many astronomers compared it to a once-in-a-millennium alignment. The giant wasn't simply passing by. It was aiming toward another interstellar visitor already threading its path near our Sun. From the moment its orbit was confirmed, urgency turned into a scramble. The solar system had just become the stage for an encounter unlike any in recorded human history. Once astronomers had the intruder in their sights, the race began to decode what exactly they were looking at. Size estimates placed it in a category all its own. Not small enough to be dismissed as a comet, not round enough to be classed with dwarf planets, and far more massive than any asteroid that had wandered into our instrument's view. The closest analogy was staggering. A fragment the size of Manhattan drifting between the stars. Its outline told a story of violence. Unlike a tidy sphere shaped by billions of years of gravity, the giant appeared jagged and irregular, like a colossal shard torn from a larger world. Surface imaging revealed deep grooves and ridges, scars that may have been carved by past collisions or tidal stresses. Then came its spin. Most natural bodies rotate predictably, but this giant's motion wobbled erratically, sometimes speeding up, other times slowing down, almost as if mass inside was shifting unevenly. Was it layered like a planet? Could hollow caverns lurk beneath its surface, preserving pristine material untouched since the dawn of its creation? Adding to the intrigue were faint emissions detected along its trailing edge. Not the icy jets we expect from comets, but something heavier, granular dust that clung stubbornly to its gravity, escaping in thick, irregular bursts. Spectroscopy revealed hints of unusual compounds, hydrocarbons darker than tar, sulfur-bearing molecules rare in our system, even metallic vapors that suggested ancient planetary processes. This wasn't just a rock adrift in the void. It was a geological archive, a wandering fossil forged in alien conditions, carrying within it the coded story of another star system, and it was now heading straight for 3I/ATLAS. If its size alone didn't command global attention, its trajectory sealed the deal. This was not a body that belonged here. Its path sliced into the solar system at an oblique angle, crossing the planetary plane in a way that screamed of foreign origins. Its velocity, faster than most cataloged comets, meant it had been traveling for millions of years, set adrift by some long-forgotten violence near a distant star. At first, models suggested it would swing by harmlessly, curving back out into the dark, but refinements painted a more shocking picture. Its line of approach intersected almost exactly with that of 3I/ATLAS. Two alien travelers, both exiles from other systems, were converging in our cosmic backyard. The odds of such an alignment were astronomically small. It wasn't just that they would enter the same system, it was that their trajectories crossed within the same narrow corridor, separated only by weeks of travel time. Astronomers spoke of cosmic billiards and celestial chessboards, where gravity plays moves we can barely anticipate. Speculation erupted. Could the two objects once have been bound together, a binary pair torn apart by a supernova or rogue planet, now reunited by sheer chance? Or was this nothing more than blind coincidence in the endless randomness of space? Whatever the answer, the implications were profound. If they passed close enough, they could tug at each other's orbits, exchange material, or in the rarest case, collide. The possibility of such an encounter turned observation into obsession. Once the intruder's trajectory was confirmed, the global scientific community shifted into emergency mode. This wasn't a typical object you could schedule for next month's observing run. Every second mattered, from Hawaii's Mauna Kea observatories to Chile's Atacama Desert telescopes, from the Hubble and James Webb Space Observatories to smaller university arrays. Instruments were repointed and recalibrated. Agreements that once took years of negotiation were signed in days. Data sharing became instantaneous. Nations that rarely cooperated on anything else found common ground in tracking this colossal visitor. Different wavelengths told different parts of the story. Radio telescopes listened for electromagnetic whispers. Infrared sensors hunted for heat signatures, hoping to reveal what lay beneath its darkened shell. Ultraviolet arrays scanned for outgassing trails. Even plasma detectors in orbit began to pick up disturbances in the solar wind, ripples caused by the giant's sheer presence. Meanwhile, proposals flooded in to redirect spacecraft already in deep space. Could probes on their way to Jupiter or Saturn perform a trajectory adjustment to intercept it? Could we position dust collectors to capture fragments if the object shed material during its encounter with ATLAS? The window was narrow, but the opportunity was unparalleled. For astronomers, it was a chance to witness in real time what had previously existed only in computer simulations. Two interstellar travelers brushing past each other under the gaze of the sun. The stakes weren't just scientific, they were historic. Humanity might only get one look at such an event, and missing it was not an option. With the intruder now fully confirmed, one question echoed louder than any other. What exactly is it? Three competing theories quickly rose to prominence. Spectroscopic data hinted at metals and sulfur-rich compounds, the kind more likely found deep inside a differentiated world. If true, this giant wasn't just a stray boulder. It was the broken heart of an alien planet, ripped apart by some ancient catastrophe. Perhaps a collision with another planet. Perhaps the death throes of its host star. This theory explained its abnormal density and irregular spin. It might even carry a magnetic memory of its birthplace, fossilized within metallic veins. Others suggested something even older. Maybe it was a preserved remnant from the galaxy's earliest days, forged before planets even coalesced. Its chemistry could reveal element ratios locked in place billions of years ago, giving us not just the history of one star system, but of galactic evolution itself. The most tantalizing theory was that the newcomer and 3I/ATLAS were siblings, fragments expelled from the same ancient system, maybe even from the same body. If their compositions matched, humanity might be staring at a reunion across light years, two cosmic castaways finding each other again by the sheer mechanics of gravity. Each theory carried staggering implications. If it was a planetary core, we'd be peering at geology from a world that no longer exists. If primordial, it could rewrite our understanding of galactic chemistry. And if a twin to Atlas, it might prove that interstellar fragments travel in pairs, changing how we model stellar ejections. For now, no single explanation won the day. But the closer the two travelers drew, the more data would flow, and the more the universe's secrets would spill. With two interstellar bodies on a collision course, or at least a near pass, astronomers began running scenarios. Each outcome carried drama and discovery in equal measure. The most likely outcome, according to simulations, was that the two bodies would swing past each other closely. Their mutual gravity could tug at their trajectories, altering both paths. Atlas, the smaller of the two, might shed plumes of gas or even fracture under tidal stress. The larger body might slough off fragments, exposing fresh interior surfaces never seen before. For scientists, even this gentle dance would provide a laboratory in motion. A rarer but thrilling possibility. The giant could briefly capture ATLAS, pulling it into an unstable binary. For days, weeks, or months, the two might orbit one another before flinging apart again. Such an event has never been directly observed in our skies. Witnessing it would reveal dynamics usually left to computer models. The least likely, but most spectacular, possibility was impact. At their extreme velocities, even a glancing strike would unleash energy dwarfing anything Earth has ever recorded in space. Dust plumes would stretch across millions of miles, visible even with amateur telescopes. For researchers, it would scatter priceless fragments into the void, a cosmic autopsy of two alien bodies. No matter which scenario unfolded, humanity stood to gain. Each outcome promised new insights into interstellar chemistry, structure, and the sheer mechanics of celestial encounters. For the first time, scientists were not just speculating about distant galactic processes. They were watching them play out live, right here in our solar system. The stage was set. The only question was, what act would the universe choose to perform? Though astronomers reassured the public that neither Atlas nor the gigantic newcomer posed a direct threat to Earth, planetary defense experts still paid very close attention. Not because these two visitors could strike us, but because their encounter offered a rare chance to test real-world models of what might happen if such giants ever did cross Earth's path. The incoming body's sheer size, comparable to a city, forced simulations to confront uncomfortable realities. If an object of similar mass and velocity ever aligned with Earth, no current deflection strategy would be sufficient. Even nuclear intercepts would barely alter its trajectory. Observing how this giant interacted with Atlas became a natural experiment, a stress test of cosmic mechanics on scales we could never replicate in labs. Agencies discussed opportunistic missions, redirecting probes in the outer solar system, equipping them with dust collectors to snag any fragments shed in the encounter. Even tiny particles, captured and returned, would be priceless samples of alien geology. For planetary defense planners, the event was both humbling and motivating. It reminded humanity that our solar system is not an isolated bubble, but an open corridor where wanderers from across the galaxy can, and do, arrive unannounced. As the countdown to the encounter ticked closer, humanity responded not just with science, but with awe. Planetariums streamed nightly updates, families gathered under domes to watch simulations, and schoolchildren asked what it would feel like to stand on such a body, gazing at a star, not our sun. Artists, too, found inspiration. Musicians turned plasma wave data into eerie soundscapes, letting audiences hear the interstellar traveler's interaction with the solar wind. Painters imagined its ridged and scarred surface. Poets called it the fossil of a dead sun. Even filmmakers rushed to animate its possible dance or collision with ATLAS, blending hard science with human imagination. For many, the event recalled ages past when comets were seen as omens. But unlike our ancestors, who greeted celestial arrivals with fear, modern societies leaned into curiosity. The giant object became a symbol, not of doom, but of perspective, a reminder that we are part of a galaxy still full of mysteries, where events unfold across scales that dwarf human history. In deserts, on mountaintops, and across city rooftops, communities gathered to look up together. It became not just an astronomical milestone, but a cultural one, a generational moment of wonder. And so, the stage is set. A colossal fragment from another star system presses inward, its scarred surface whispering tales of alien origins. Ahead of it waits 3 I/A/TLAS, smaller but no less mysterious, itself already a messenger from the void. In days or weeks, the two will pass within reach of our instruments, perhaps close enough to tug, fracture, or even collide. Whatever happens, the data will echo through science for decades. Each spectrum, each image, each plasma wave recorded will become a chapter in humanity's growing book of cosmic encounters. For now, we watch, we model, we speculate, and we marvel. The solar system itself has become a stage for a drama written across light years, and we, by chance of timing, are here to witness it unfold. If you enjoyed this deep dive, don't forget to like, subscribe, and share your thoughts below. Will they dance, collide, or pass silently in the night? Let us know what you think.